Good morning. Thank you very much for attending. My name is Oriol Radoy. I'm a mechanical engineer specialized in smoke control, and I'm a member of the smoke control project department at SODECA. Today, we continue with a series of 4 webinars focused on pressurization systems for evacuation routes. In the first webinar, I talked about the objective of a pressurization system and the system classification according to the European standard EN 12101/6. In the second webinar, I talked about airflow calculation for fan selection. In this third webinar, I will talk about the components of a pressurization system. And in the fourth webinar, I will talk about the new European standard for design, installation, and maintenance of pressurization systems, the new standard EN 12101/13. Your microphones are on silence mode in order not to disturb the listening of the other attendees. And if you would like to ask me a question, please write it in the question box of your panel, and I'd be glad to take all your questions at the end. Okay, let's start. Well, this webinar will have two parts. One of system components and the other one of SODECA pressurization equipment. Let's start with the components. Well, first of all, we need to control the pressure inside the stairwell. And in order to control this pressure inside the stairwell, the European standard, the EN 12101/6, gives us 3 possible methods. The first one is the dampers opening to the outside to vent excess airflow. And in this case, the airflow rate of the fan remains steady. The second method is to apply or to install dampers in ducts in order to create a bypass. And in this case, again, the airflow rate of the fan remains steady. And finally, the third method is to install an inverter to control the fan speed to maintain a set point of 50 pascals via signal from a pressure sensor. This is what we use in our SODECA pressurization control panels. In this case, in the closed door scenario, the pressure will be 50 pascals inside the stairwell, and the fan speed and the airflow will be modulated. And for the open door scenario, the fan speed and the airflow will be the maximum that the fan can give, and the pressure will be the resulting, depending on the number of doors that are open. Here in the screen, you can see in the right-hand side the different components. For the moment, we have the supply fan. In this case, in our equipment, we have the variable frequency drive and the differential pressure sensor. And we will add different components step by step. The following thing to talk about is when we need a standby fan. As per the EN 12101/6, where the pressure differential system equipment provides air to the only escape route within a building, a standby fan should be installed. And this standby fan should be the same type and capacity as the duty fan. And the switch between the duty fan and the standby fan should be automatic. It means that if the duty fan fails, the standby fan should run automatically. The standby fan and the duty fan can be installed in parallel or in series. If we install them in parallel, backdraft dampers should be installed at each fan in order to avoid bypass. And when we install them in series, we have to consider the losses that the standby fan produces to the system. They are called idling losses. Okay, so the static pressure of the fan should be increased in order to overcome these losses. With regards to the air intake, the standard says that this air intake should always be located away from any potential fire hazard. Air intakes should be located on or near the ground level to avoid contamination by rising smoke. But if this is not possible, air intakes should be positioned at roof level with smoke detection in order to close the damper affected by the smoke. It means that if we install the air intake at the roof level, we need at least 2 different air intakes with a motorized damper and a smoke detector at every air intake. And at the beginning, we can have both dampers opened, but in case that one of the air intakes is contaminated by rising smoke, this motorized damper should close and remains open the other one. So now we have supply fan, the variable frequency drive, differential pressure sensor, a standby fan when needed, and we see motorized damper and a smoke detector for the air intake. With regards to the distribution ductwork, for multi-story buildings, the preferred pressure differential system distribution is a vertical duct running adjacent to the pressurized spaces. When this distribution ductwork is completely inside the stairwell, there is no requirement of fire resistance, because bear in mind that this ductwork is carrying fresh air, not smoke. But when the distribution ductwork passes through other fire compartment, it must be protected, or it must have fire resistance and therefore be classified in accordance with the European standard EN 13501 Part 4. The system design must ensure a uniform air distribution throughout the protected space and must prevent air from passing directly out of an open door as soon as it has been supplied to the protected space. So do not install air supply points near doors. And each protected space, stairwell, lobby, and sometimes corridor, shall be provided with its own dedicated pressurization system. The lobby shall have pressurization air supply through ductwork that is independent of that supplying the stair, and the corridor shall have pressurizing air supplied from a duct that is separate from the lobby and the stairwell supply. In buildings less than 11 meters in height, a single air supply point for each pressurized stairwell is acceptable, but in buildings 11 meters or more in height, air supply points shall be evenly distributed throughout the height of the stairwell, and the maximum distance between air supply points shall not exceed 3 stories. No supply point shall be located within 3 meters of the final exit door, and for lift shafts, 1 injection or supply point shall be provided for each lift shaft up to 3 meters in height. Now I'm going to talk about the air release. Sometimes this is one of the most difficult components to install, because there's sometimes problems with the space or where to install them, but it's very important to have it in order that the system works properly. So during the operation of the system, pressurizing airflow will flow from the pressurized space, the stairwell, into the accommodation. So provision must be made on the fire story for the air that has leaked into the unpressurized, the accommodation area, to escape from the building. So we are supplying air into the stairwell. This air will leak to the accommodation area, and we have to provision the building with this air release in order that this air flows from the accommodation area to the outside. This is essential in order to maintain the pressure differential between the pressurized space, the accommodation area, in the closed door scenario, and to ensure the air speed through the open door in the open door scenario. So now we have supply fan, variable frequency drive, diffraction pressure sensor, standby fan when needed, motorized damper and smoke detector for the air intake, and air release points. All of this is needed in order the system to work properly. With regards to the air release, the accommodation on the fire storage shall have a specific provision for air release for the intended flow rate entering the space. Okay, they have to be dimensioned according to the air that flows from the stairwell to the accommodation. The standard says that if it can be shown an appropriate fire by an appropriate fire engineering study that sufficient leakage paths via the ventilation system will be available prior to window breakage, it is not necessary to provide additional provision for air release from the building. But if this cannot be demonstrated in absence of this study, the standard gives three different possibilities for the air release. The first one is special vents at the building facade. In this case, the automatic opening vent at the facade at the fire level should be open. The second method is a natural vertical shaft with multi-compartment smoke dampers at every level, and only the smoke damper at the fire level should open. And finally, the third option is a vertical shaft connected to an extraction fan, and again with multi-compartment smoke control dampers at every level, and again only opens the smoke damper at the fire level. In this case, the dimension or the area of the duct can be smaller than the one in the previous with the natural vertical shaft. We at SODECA, we have this PDS lobby control device. It has a pressure differential sensor built in, but it also allows the opening of smoke dampers or of automatic opening vents. Okay. And now I'm going to talk a little bit about the SODECA solutions for pressurization systems. We have three different ranges of product: the basic, the advanced, and what we call the full range. In the basic, we have this kit sobre presión. We have been producing this product for a long time. And then we have developed in the last years other more advanced equipment, the Kitbox Press Plus, the Kitbox Smart, and the most advanced equipment that we have is the Kitbox PDS. Starting with the most advanced equipment, we have the Kitbox PDS and the new Kitbox PDS Smart. Both consist of an axial fan. The box PDS pressurization control panel that includes the electronic control, the pressure sensor, an inverter, and also power supply batteries according to the EN 12101 part 10. These batteries are for the electronics of the panel, not for the power of the fan. But in case of failure of the power, when the building recovers the power, all the electronics are still working, so the system can work again very quickly. It also has this damper box, this motorized damper with a fast response actuator with just 2.5 seconds opening and closing. and it has a built-in smoke sensor. This is for the air intake. It also has an external control panel with a pressure display, a state of the unit, alarms, and manual activation of the system. This is intended for maintenance and for the use of firefighters. And as an optional, we can connect a number of PDS lobby controls to the Box PDS control panel. This device allows independent automatic regulation, and it can be connected to the Box PDS panel. We use them basically for lobbies. Okay, we can install one PDS lobby control at every lobby, and if you remember, the first webinar said that when we have to pressurize lobbies, we have two options. We can pressurize all the lobbies at the same time, or we can pressurize only the lobby at the fire level. But then we need to control the level, the pressurization level at this lobby. So we need one of these devices at every lobby, and the speed of the fan will be controlled by the pressure difference that gives the PDS lobby control at the lobby of the fire level. Okay. Talking about this damper box, this motorized damper with the fast response actuator and a built-in smoke detector. If we install the air intake at the ground level, only one of these devices, of this damper box, is needed. But if we install them at the roof level, we need two air intakes, and they should be installed at different facades. A little bit about this PDS lobby control. It allows the management of motorized dampers. Okay, if we choose the way that we only pressurize the lobby at the fire level, we need motorized dampers at every lobby, and only the motorized damper at the fire level should open and remain closed the other dampers. So it has also a pressure differential sensor built in, so it gives us the information of the pressure differential to the Box PDS control panel in order to control the pressure in the lobby. It also can manage the air release smoke damper. So as we can see, it has it allows the management of the motorized damper to supply air into the lobby, but also the air release at the fire level. And for some applications in high-rise buildings where we have high stairwells, it allows the management of a proportional damper. These proportional dampers could be installed in a high-rise building in the stairwell, sorry, in order to supply the appropriate airflow at every level of the stairwell. Instead of having grills in the stairwell, we could install proportional dampers. So if we have a difference of pressure along the stairwell, we could supply more air where is needed. Okay, the activation of this PDS lobby control can be done via signal of the building fire panel, or via point detectors on each floor. Well, now we follow with the Kit Box Smart or Kit Box Smart 2. When you see this number 2 in Roman numbers, it means that is the equipment with a standby fan. Okay, it goes with only one pressurization control panel, but when we have these two two fans are connected to the pressurization control panel, and in the event of the failure of the duty fan, the standby fan will run automatically. Again, we need a fan here, and this Box Smart panel includes the pressure sensor, the inverter, thermal magnetic protection, and it has an internal memory to save the last status in case of power loss. Okay, it also has confirmation signals for communicating with the fire detection system, and it allows the connection of this device, the SI calendar, in case that you want to use this equipment for daily ventilation. And an external control panel, we call it CM panel, can be connected to the Box Smart panel in order to be installed at the entrance of the stairwell for the use of the fire brigade. It has the possibility of manual activation, so it can be installed near the entrance door of the stairwell, just in case that the fire brigade wants to activate the system if the system has not been activated automatically, or the other way around, to stop the system if they consider that they have to stop the system. This Box Press Plus panel, well, the difference is that, sorry, I haven't said that with this KitBox Smart, we can connect the damper box, one or two. One, if we install the equipment of the air intake on the ground floor, or two, if we install the air intake at the roof floor. The difference with this other panel is more or less the same that the Box Smart panel, but in this case we cannot connect the damper box system. In Europe, we need to install these motorized dampers with built-in sensors at the air intake, but in other countries there is no need. So we have this equipment for places or countries where there is no need to have the damper box. And finally, this is our first equipment that we produced many years ago. We still produce this because there are in many countries they still use this equipment, but it's the most basic equipment. It has the pressure sensor, the inverter, and that's it. Okay, finally, as resumed, with the kit supervision, the basic one, we have the supply fan, the variable frequency drive, the differential pressure sensor, and there is the version 2 in Roman numbers to connect the standby fan when needed. The Box Press Plus, apart from what we have seen here, it allows the connection of the remote control panel. The Box Smart additionally allows the connection of the damper box, the motorized damper with a built-in smoke detector. And finally, the KitBox PDS and KitBox PDS Smart allows the management of the air release. So here we have this resume table. Now I will share with you this presentation in PDF format, so you can have all this resume table that it can be useful in order to select the equipment depending on the needs of your country or the standards that you have to comply with. Okay. So with this, I have finished the presentation. Now I'm going to share this presentation in PDF format, and if you have any question, I'd be glad to answer them. You can write it in your control panel, and I will answer them. Just 1 second, I'm going to share. Okay, I think now it's sharing. Yes. Okay. And I go to the question panel here. Okay. Okay, first question. Hello, and a certificate for attendance. Okay, please write an email to our communication department. This is communication at SODECA.com. And please ask them, because this matter is in their in charge of this communication department. Another question: what pressure loss we need to take into account when using two fans in series? Good question. There is not. I cannot say a number now, because it depends on the airflow and the size of the fan. We have some graphs in order to calculate this, what we call the idling losses. And depending on the airflow and the selected fan, then we can know the losses of that the standby fan produces, and then we give this pascals, or this pressure, static pressure, to both fans, not only the duty fan, but also to both fans. Next question. Thanks, very clear. Thank you. Next question. If we have a 10-story building and on each level we have a pressurization damper, can we connect to one pressurization kit? Yes, with the Kitbox PDS smart equipment. Okay, the equipment that allows to connect different pressure differential sensors, or let's say the PDS lobby control, is the Kitbox PDS Smart. Okay. Okay, my colleague Amin, can you please do a fast comparison between the EN and the F and the French standard? Well, this cannot be fast, my colleague. But yes, well, the French standard, you have two methods, method A, method B. Maybe one day we'll have to prepare a webinar for the French standard, but it cannot be fast. Okay, the comparison between the European and the French standard. How many dampers can we connect to one pressurization kit? I guess that you mean, Mr. Dragoman, you mean air intake dampers. With the Box Smart, we can connect up to 2 box air intake dampers, and with the new Kitbox PDS Smart, we can connect up to 3 air intake dampers. Can we have the previous session in PDF? Okay, let me look for them. Just 1 second, and I will share with you the. Okay, here, webinar number 2, and also just 1 second. Webinar number 1. Okay, I have just shared with you the previous webinars in PDF format. What else? Do you produce backdraft dampers with pressure difference kit? Well, we produce them, but we is an accessory. okay, is if you go to our QuickFan software and you go to, let me show you, just 1 second. I'm going to open the QuickFan software. Okay, 1 second. Okay, here we have it in English. Okay, you go here to catalog and accessories. I would recommend to use these ones, the P400 we call them, okay? And if you go in, you have models. And for instance, if you are installing Kitbox PDS 2, let's say that you need, for instance, this one, okay, the Kitbox PDS 2 1000. It has okay, 2 fans and 1 control panel, the duty fan and standby fan. If you install them in parallel, okay, then you have these dimensions, and the P400 100 fits perfectly well with this fan. Okay, then you should, here you have the losses that this damper produces, and you should select 2 of these in order to install 1 to each of the 2 fans. Okay. When you use the controller EC control to do pressurization of the stereo with a ventilation box, I recommend not to do so. I mean, some of the pressurization kits of the Box Smart and Box Press Plus, they use EC motors, but only with that pressurization kits we recommend to install it. But the PDS lobby control is especially designed for pressurization of evacuation routes. I mean, the difference between the EC control, and the PDS lobby control is that the PDS lobby control allows us to connect the dampers, and it's already set to maintain the 50 pascals of pressure difference. So it's especially designed for pressurization of evacuation routes. What solution we have when an existing staircase higher than 11 meters in height is not foreseen with ductwork and impossible to install? So only one air inlet on the top or on the bottom. Good question, and you know, it happens many times. Well, we have here. I would like to talk about two different things. One of them is that the new EN 12101 Part 13, the new pressurization standard for design, does not mention this point of the 11 meters. Okay, so it seems that maybe 11 meters is a very low height as to, let's say, require this tag. But you know, if we have to comply with the European standard, the 12101 per 6, we have 2 options: or try to install the DAC, or if not, then there is another option, but it's more complicated. It is go to a performance-based design. Performance-based design, it means that we have to, let's say, demonstrate that we have the performance that is required to the system with different kinds of calculations. Most used calculation is a CFD simulation in order to check that the system will perform as expected. But you know, this means a lot of extra work, but it's the only way that we can ensure that the system will perform as expected. What else? Is SODECA able to perform this CFD? Actually, we can perform a CFD, but not a performance-based design. And a CFD simulation, bear in mind that it's not a performance-based design. It's only a part of the performance-based design. Performance-based design, you can follow, for instance, the ISO 23932 part 1. That is, well, you have there the methodology to carry out performance-based design, but the performance-based design is something else than just a CFD simulation. So you probably need someone who carry out the performance-based design, and then it will give you the information as to carry out the CFD simulation. But I would recommend to contact with a consultant that can carry out the whole performance-based design. Okay, what else? Can we use the controller EC control to do pressurization of a stairwell with a ventilation box with an EC motor instead of using Box Smart EC? I would not recommend this solution because, you know, these systems are safety systems, and all of the pressurization systems, the Box Press Plus, the Box Smart, Kitbox PDS, etc., are designed as safety systems. Okay, so for instance, the variable frequency drive has the fire mode, and they have other characteristics or specifications in order to comply with the safety requirements. And EC control can control the pressurization, yes, but they are not meant for safety systems. So we don't recommend to use them instead of using the pressurization control panels. Yes, here is a question. I would like to install BDD as compensation for corridors. Could you, I'm sorry, but could you clarify what BDD, what you mean with BDD, please? Mr. Nikolai. Backdraft dampers, okay. I would like to install backdraft dampers. Well, but no, I would not recommend to install them as compensation for corridors because they are with backdraft dampers. The purpose of a backdraft damper is to avoid backdraft flow, but we cannot control the difference of pressure when they open. So when you need a compensation, yeah, but I would say that it's not the best option. At least our backdraft dampers for this solution. Well, it depends of every project. I don't know. If you want to email us and give us more information about the project, we can recommend or not, or we can recommend another solution. I would need information about the project, and then we can answer. But I prefer not to answer a yes or no without knowing, without having more information about the project. You're very welcome. Okay, I don't know. I think there are not more questions. So, well, thank you very much again for attending. And in 2 weeks' time, I will give the last of this series of 4th webinars about this one will be about the new European standard, the EN 12101 part 13. I invite you to assist and to attend, sorry. And just thank you again and see you soon.